Coordinate geometry. Dear children, welcome to today's class. In the last class, we have studied about the distance between 2 points in the Cartesian plane, that is, the distance formula, and some application problems based on the same. Let us recall the distance formula again. The distance between 2 points Px1, y1 and Qx2, y2 is PQ equals square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now, I am going to discuss a situation here. Listen carefully and at last I will ask a question to you. Consider a line segment AB in which x1, y1 be the coordinate of the point A and x2, y2 be the coordinate of the point B. Let us suppose a point P in between A and B. Suppose that P is in such a way that the distance AP equals 4 units and the distance PB equals 8 units. Or we can say that the distance PB is the double of the distance AP. Here AP by PB equals 4 by 8, which is equal to 1 by 2. Now my question is that, can you find the coordinate of the point P, that is x, y, when the endpoints x1, y1 and x2, y2 are given, as well as the ratio of the point P in which it divides the line segment AB as 4:8 or 1:2 is known for you. Here I write the section formula. Children, now we can study the section formula. Consider a line segment AB and a point P somewhere in between A and B. Here the point P is slightly nearer to A. Here the point P divides the line segment AB into two parts, AP and PB. This is called the internal division, as the point P divides the line segment AB internally into two parts. Now, let us think the point P divides AB in the ratio m1 is to m2. Now, let the point A has coordinates x1, y1 and the point B has coordinates x2, y2. We need to find the coordinate of the point P. Let it be x, y. Thus, what are the things available for us to find the coordinates of P? We have the coordinates of A and B as well as the ratio in which P divides AB. Thus, the section formula states that the coordinate of P, that is xy, equals m1 into x2 plus m2 into x1 divided by m1 plus m2, comma, m1 into y2 plus m2 into y1 divided by m1 plus m2. The section formula is used to find the coordinate of a point P when the endpoints of a line segment A and B are given and also the ratio in which the point P divides the line segment is given for you. Thus, we can summarize the section formula again as, listen to the section formula. The section formula states that the coordinates of the point P, x, y, which divides the line segment joining the points A, x1, y1 and B, x2, y2 internally in the ratio m1 is to m2 are m1 x2 plus m2 x1 divided by m1 plus m2, that is the x coordinate, and the y coordinate is m1 y2 plus m2 y1 divided by m1 plus m2. Hope all of you understand this. Okay children, and now we can start the problems based on section formula. But before that, I wish to inform you some very important facts regarding the section formula. Whenever you are given with a question, one coordinate you need to take as x1, y1 and the other coordinate you need to take as x2, y2. The second point is, the given ratio you need to imagine it as m1 is to m2. The third point is, in a ratio m1 is to m2, m1 and m2 can be called as the components of the ratio. m1 you can think as the first component and m2 you can think as the second component. The fourth point is that imagine that the first component m1 is far away from the second coordinate, that is x2, y2, and the second component m2, imagine it is far away from the first coordinate x1, y1. Now, instead of simply by hearting the formula as m1x2 plus m2x1 divided by m1 plus m2 and m1y2 plus m2y1 divided by m1 plus m2, listen to the statement I am going to say about the section formula. For to get the x coordinate of a point, you need to take the first component m1 multiply with the faraway x component x2 plus m2 you need to multiply with the faraway x component x1 divided by m1 plus m2, and the y coordinate is m1 you need to multiply with the faraway y coordinate y2 plus m2 you need to multiply with the faraway y coordinate y1 divided by m1 plus m2. This will be very helpful for you for to do the problem within the limited time. Okay, I hope all of you understand this. Then we can do some problems based on this. Okay, come to question number 1. Find the coordinates of the point P. A point P is given. We are asked to find the coordinate of the point which divides the line segment joining the points 4, -3 and 8, 5. Two coordinates are given that you can take at the points x1, y1 and x2, y2. For each and every question in this section formula as well as in coordinate geometry, the figure seems to be very important. Let Pxy is the required point. It is given that the coordinate of the point P or the point P divides AB in the ratio 3:1 internally. 3:1 means that this you can think as M1, the other one you can think as M2, and X1 and Y1 is given for you. Now, using this section formula, two methods are here for to find. First is the direct method, in which, just like the formula, M1 here is 3 and M2 is 1. So, I am going to write in this way. M1 you need to multiply with the faraway x coordinate 8 plus M2 you need to multiply with M2 is 1, that you need to multiply with the faraway x coordinate 4 divided by M1 plus M2 is 3 plus 1. This will be the x coordinate of the point, and M1 you need to multiply with the faraway y coordinate 5 plus M2 you need to multiply with the faraway y coordinate -3 divided by M1 plus M2. Looking at the figure, and we can do that. That is the direct method, which is equal to 8 3s are 24 plus 4 divided by 4, comma 5 3s are 15 plus -3 divided by 4. So the answer is 28 by 4, and 15 minus 3 is 12 by 4. So you got the answer as 7 3. So the coordinate of the point P is 7 3. I hope you understand this direct method. And method 2 is in which, if a student fails to do the direct method, they can apply the substitution method. In the substitution method, what you want to do, that you need to collect the values of x1, y1, which is given as 4 -3. Then the value x2, y2, which is given as 8, 5. And one more thing is given for you. The ratio m1 is to m2 is given as 3:1. Now apply the direct section formula. By the section formula we have, you can write the formula there. The coordinate of the point P, which is xy, write the formula at first. M1 into x2 plus m2 into x1 divided by m1 plus m2. That will be the x coordinate, and m1 into y2 plus m2 into y1 divided by m1 plus m2, that is the y coordinate. Now I am going to substitute values here. What is the value of m1? m1 is 3 into x2 is 8 plus m2 is 1 into x1 is 4 divided by m1 plus m2 is 3 plus 1, comma. Then again m1 3 into y2 is 5 plus m2 is 1 into y1 is minus 3 divided by m1 plus m2 is 3 plus 1. There also you will get the answer. 8 into 3 24 plus 4 28. 28 by 4 is 7 and 15 minus 3 12 by 4 3 is the answer. Anyway, both the answer will be same. Which method is easy for you that you can adopt? I will discuss one more question. Wait, not a same one. It's the direct question. Question 2. Find the coordinates of the point P which divides the line segment joining the points 3, 5 and 7, 9 in the ratio 2:3. Here the ratio is given as 2:3, which is your m1 and m2. Okay, by direct method I am going to do, which is how m1 into the faraway x coordinate 7, m1 is 2 into the faraway x coordinate is 7 plus m2 3 into the faraway x coordinate 3, 3 into 3 divided by the ratio 2 plus 3, 2 plus 3, and the other component is, or the y coordinate is m1, this is your m1 and this is the m2. m1 you need to multiply with the faraway y coordinate 9, m1 is 2 into the faraway y coordinate is 9 plus m2 is 3, you need to multiply with the faraway y coordinate 5, 3 into 5 divided by m1 plus m2. This seems to be easy. Just looking at the figure and do. m1 you need to multiply with the faraway coordinate. m2 you need to multiply with the faraway coordinate in this way. Now, which is equal to 7 2s are 14 plus 3 3s are 9 divided by 5, comma, 9 2s are 18 plus 5 3s are 15 by 5. So that your answer is 23 by 5 and 33 by 5. Okay. Now we can come, this is method 1, the direct method. Just looking at the figure and do. Method 2 is that you need to collect the values of x1, y1, which is given to us 3, 5. Then x2, y2, which is given to us 7 and 9. And the ratio is given m1, m2 is given to us 2:3. Just direct application. By section formula, you can write the formula there. By section formula, the coordinate xy must be equal to, write the formula, just the substitution, m1 x2 plus m2 x1 divided by m1 plus m2, comma, the y coordinate is m1 y2 plus m2 y1 divided by m1 plus m2. Now, I am going to substitute the value here, where m1 is 2 into x2 is 7 plus m2 is 3 into x1 is 3 divided by m1 plus m2 is 2 plus 3, comma. Then again, m1 is 2 into y2 is 9 plus m2 is 3 into y1 is 5 divided by m1 plus m2. Just direct substitution equals again 14 plus 9, 23 by 5 will come here, and here 9 to 18, 18 plus 15, 33 by 5 will come here. Anyway, both the answers are same in both the cases. So the coordinate of the point P is 23 by 5 and 33 by 5 is the coordinate. I hope all of you understand how to do this. Now, we can discuss with another question. This question seems to be very important. Question number 3. Very important question. Look at the question. Find the coordinates of the point of trisection. What do you mean by trisection? Trisection means divide something into 3 equal parts. For to divide something into 3 equal parts, how many points you want? 2 points we need. Let them be taken as P and Q. For to divide something into 3 equal parts, we want 2 points. Look at this one now. 1 is to 1 is to 1. Dividing into 3 equal parts means that the same ratio. This much is you can take as 1. This much length you can take as 1. This you can take as 1. This you can take as 1. Means that all are equal length. Suppose if the ratio is 4 is to 4 is to 4. Then reduce you get 1 is to 1 is to 1. If it is 8 is to 8 is to 8, then again 1 is to 1. That is dividing into 3 equal parts means that all the components will be same. Okay. Now, let P and Q be the points of trisection. Find the coordinates of the point of trisection is the question. Trisection means that a point dividing in 3 equal parts. Of the line segment joining the points A2 minus 2 and B minus 7, 4. 2 coordinates are given. You need to find the points of trisection. So, 2 points you need to find. x1, y1 as well as x2, y2 that we can take. So, figure you need to draw. Then, let P and Q be the point of trisection. Means that what is meant by trisection? AP equal to PQ equal to QB. All the lengths will be same. AP equal to PQ equal to QB. Now, at first I am going to find the coordinate of the point P. Now, I am going to convert the figure like this. Ignoring the point Q or forget about the point Q, I am going to find the coordinate of the point P at first. What is the point P? The peculiarity of the point P. Now the point P divides the line segment AB in the ratio 1 is to 2. Listen to this. 1 is to 2 part here. Therefore, the coordinate I am going to apply the direct method xy or x1, y1. This is my coordinate x1, y1 equal to direct application. 1 into the faraway coordinate minus 7 plus 2 into the faraway coordinate 2. 2 into the faraway coordinate 2 divided by 1 plus 2 is the ratio component, comma. Again, 1 into the faraway y coordinate 4. 1 into the faraway y coordinate 4 plus 2 into the faraway y coordinate minus 2. 2 into minus 2 divided by 1 plus 2. So, we can do this. What about 1 into minus 7? Minus 7 plus 2 into 2 is 4 divided by 3, comma 4 plus minus 4 divided by 3. So, your answer is minus 3 by 3 and 0 by 3. That is minus 1, 0 is the coordinate of the point P. Okay. Now, come with the second part. I found the value as minus 1, 0. Now, I want to find the coordinate of the point Q. As it is trisecting, we need to find both the coordinates. Now, I am going to find the coordinate of the point Q. Listen to the point Q. Now, the peculiarity of the point Q is that suppose you ignore the point P, the point Q divides the line segment AB in the ratio 2 is to 1. Am I right? This much is 2 part and this is 1 part. That figure I drawn here separately. A and B having the same coordinates 2 minus 2 and minus 7, 4. But the point Q divides AB in the ratio now 2 is to 1. Okay. So, we are going to find the coordinate x2, y2. Direct application which is equal to 2 into the faraway h coordinate minus 7, 2 into the faraway h coordinate minus 7 plus 1 into the faraway h coordinate 2, 1 into 2 divided by the ratio component again is 2 plus 1 and the y coordinate is 2 into the faraway y coordinate 4, 2 into the faraway y coordinate 4 plus 1 into the faraway y coordinate minus 2 divided by 2 plus 1. Now, which is equal to 2 into minus 7 is minus 14 plus 2 divided by 3. And here 8 plus minus 2 divided by 3. So your answer is here minus 14 plus 2 is minus 12, minus 12 by 3, and here 8 minus 2 is 6 by 3. So the answer is minus 4, 2 is the answer. Thus the coordinates of the point of trisection are minus 1, 0 and minus 4, 2. So very important question for to find the points of trisection. For to find the trisecting points, you need to take it as P and Q. Remember, P divides AB in the ratio 1:2, but Q divides AB in the ratio 2:1. Very important question. Now we can discuss with one more question. That also seems to be a very important question. Look at question number 4. The question is that the point R divides the line segment AB, where A is given as minus 4, 0 and B is given as 0, 6. The condition is that AR equals 3 by 4 of AB. AR, this much is 3 by 4 of AB, means that total AB length, 3 part come here and the remaining 1 part come here. Am I right? Then only we can say that AR equal to 3 by 4, the total 4 parts. Among 3 part is for AR and the remaining 1 part is for RB or BR. So when the ratio is given as a fraction like this, you need to find the ratio components as 3:1. Don't take it as 3:4. A very important question. When the ratio, instead of the ratio component directly, if you are given with the ratio as a fraction 3 by 4 of a line segment AB, then you need to find the ratio as this much is 3 and the remaining 1 part will come here. You are asked to find the coordinate of the point R. Let the coordinate of the point R can be taken as x, y. Now here the required ratio is 3:1. I hope you understand how we got the ratio as 3:1. Among the 4 part of the denominator, 3 part is for AR and the remaining 1 part is for RB. Or here AR equals 3 by 4 AB. From this you can say what about RB? RB equal to the remaining 1/4 of AB. That is why you need to take the ratio as 3:1. Using the section formula, you are asked to find the coordinate of R. Okay. By section formula, I am going to do the direct method. X, y equals. Okay, we can do 3 into the far away x coordinate 0. 3 into the far away x coordinate 0 plus 1 into the far away x coordinate minus 4 divided by the ratio component sum is 3 plus 1, comma. Then 3 into the far away y coordinate 6. 3 into the far away y coordinate 6 plus 1 into the far away y coordinate 0. 1 into 0 divided by the component 3 plus 1. Okay, now we can simplify, which is equal to 3 into 0 is 0 plus minus 4 divided by 4, and the other one is 6 into 3 is 18 plus 0 divided by 4. So the answer is minus 4 by 4 and 18 by 4. Okay, this you can convert as minus 1 by 18 by 4 can be cancelled with a 2. You get 9 by 2 is the answer. So very important question. How to find the coordinate of a point P or R when instead of the ratio is given as a fraction or AR is given as 3 by 4 of AB. So I hope that all of you understand this question. The first one is the 3 questions we discussed. The first one is a direct question. The second one is the point of trisection. Point of trisection means dividing into 3 equal parts, in which the first part the ratio you will get as 1:2, and for the second part you will get the ratio as 2:1. And the last question, in which instead of given as the direct ratio, you are given with as the ratio as a fraction, and find the ratio components from it and find the required coordinate xy. So this section seems to be very important. The following are the homework questions to you. Thank you.